As we get ready to talk about Bohr-Rutherford diagrams, I just want to take a second to go through. We mentioned some of our subatomic particles before. I just want to have a chance to organize them before we start talking about Bohr-Rutherford diagrams. So we're going to look at three different subatomic particles today that exist in the Bohr-Rutherford diagram. Subatomic means smaller than an atom. So there's lots of different subatomic particles. We only talk about three in high school science. We talk about the nucleus, the proton, and the electron. So we mentioned these words before. Let's talk about what they actually look like. So we have three different subatomic particles that exist in the atom. Let's take a look at their charges first. So a proton is said to have a positive charge, an electron is said to have a negative charge, and a neutron is said to be neutral. So overall, in a neutral atom, there's equal numbers of positives and negatives. So the positives balance out the negatives, and you're going to see a neutral charge. The mass, what do they weigh? So a proton and a neutron are both said to weigh one. One what? I'm sure you're asking. They're very, very, very small. They're incredibly light. So we actually made up a unit called AMU, atomic mass unit. So essentially a proton weighs the weight of one proton, a neutron weighs the weight of one proton, and an electron is incredibly small. Electrons actually weigh almost nothing. Of course, they're still technically matter, so they do have a mass, but we call it nil because compared to the proton, they're incredibly, incredibly small. Where are they located? The proton and the neutron are both located in the nucleus. So remember, the nucleus is that dense core in the middle. So protons and neutrons are both in the nucleus, whereas the electrons orbit outside. So the electrons orbit outside these circles outside the nucleus. Remember, the first orbit can hold 2 electrons, second orbit can hold 8, and so on and so forth. So as we get into drawing our Bohr-Rutherford diagrams, I also want to talk about standard atomic notation. So in our Bohr-Rutherford diagrams, you need 2 pieces of information in order to draw your Bohr-Rutherford diagram. You need the atomic number and you need the mass number. So these are both pulled from the periodic table. Oftentimes, when we're drawing Bohr-Rutherford diagrams, scientists will first write out, or chemists will first write out what's called the standard atomic notation. So to write out a standard atomic notation, what you want to do is you want to write the element symbol. So for example, this is helium. We have the element symbol. Then what you want to do is you want to write the mass number at the top. And you want to write the atomic number at the bottom. If you are worried about confusing the two, remember the mass number is always larger than the atomic number. So your atomic number, your smaller number, is always going to go at the bottom. Your mass number, your larger number, is always going to go at the top. By laying things out in standard atomic notation, it makes drawing your Bohr-Rutherford diagram much, much easier. Your mass number and your atomic number are going to help you to determine your number of protons, and they're going to help you to determine your number of neutrons. So your atomic number, your smaller number, that's the same as your number of electrons, and it's the same as your number of protons. So the atomic number, by definition, is actually the number of protons that are in an element. I just mentioned that in neutral atoms, we are number of protons and number of electrons are always equal. So to tell the number of protons, to tell the number of electrons, you just want to go ahead and look at the atomic number. It's going to be the same. The number of neutrons, however, has to be calculated. So to calculate the number of neutrons, we're going to take the mass number and we're going to subtract the atomic number. This is going to give us the number of neutrons. If you think about it, this actually makes sense. I'm going to scroll back here. So remember that the mass, the only things that really have mass are protons and neutrons. So in this nucleus, we have protons and we have neutrons. So the mass is actually the mass of the protons and neutrons combined. So if we want to figure out just how many neutrons there are, we want to take this entire mass, we want to subtract the number of protons, and that's going to leave us with the number of neutrons. So mass number is going to be, our number of neutrons is going to be your mass number minus your atomic number. That's going to tell you exactly how many neutrons you have. Just a reminder as well too, that your first shell can fit 2 electrons, your second shell can fit 8 electrons, your next shell can fit 8 electrons, and I think based off of that, we are ready to draw our Bohr-Rutherford diagrams. So go ahead, click on the next video, and I'm going to walk you through exactly how to draw a Bohr-Rutherford diagram.